Alrighty, y'all. We are looking right now at our next part of the topic 10 notes where we talk about doing some trigonometry with the calculator. And you can see on your page right there, we're just going to start with a quick review. Okay, we're going to start with a quick review of our three trig functions that we talked about: sine, cosine, and tangent. And I put down here all of the letters that tell us what sine, cosine, and tangent are going to be. And the way we remember these letters, you may remember our mnemonic device, our abbreviation that we went with that said "some old hippie caught another hippie tripping on acid." All right, so that's just telling us that if we're talking about the sine of an angle, sine is the opposite over hypotenuse. Cosine would be the adjacent side over the hypotenuse, and tangent would be the opposite over the adjacent. All right, that's what all of this SOHCAHTOA stands for, is all of that business right there. SOHCAHTOA, that's just sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. All right, tells us what those things are going to be. So for today's exercises, we're going to need a calculator. And there's a couple things I want to point out to you. Okay, the first thing we need to check on is when you have your calculator here, you need to make absolutely sure that you are in a certain mode. And what you do is go hit this button, mode, right here. Okay, after you turn it on and clear off if there's a message at the beginning, clear it away, hit mode, and scroll down to where it says radian and degree. On these old calculators that look like this one, it'll be the third line down. On the newer calculators that I've got in the classroom, it'll be the fourth line down. And you want to make sure that degree is the thing that's highlighted. Okay, degree, not radian. We're not going to be dealing with anything with radians in this class. You might talk about them a little bit you're going to talk about them probably a good bit in pre-cal, but for geometry, we're only going to be working with degrees right now. All right. So after you've done that, just make sure you're in degrees mode. And that's going to help us and make sure that we get the right answers when we use when we use trigonometry in the calculator. So on the next page of your packet, you're going to see a bunch of tables that look like this part of it right here. Okay, this table right here on the slide is just a chunk of the table that's located on your next page. Okay, this is basically just a shorthand for what you would get if you type some stuff into the calculator. Okay, so for example, if you typed in sine of 28. Okay, you hit the sine button right there on the calculator, then inside the parentheses you put 28. Well, what you're doing is you're taking the sine of 28 degrees. So what happens is if you had a right triangle and one of the angles was 28 degrees, the ratio of the opposite side divided by the hypotenuse, that ratio would always be equal to about 0.4695. And if you type that into the calculator, that's what you would get for the same thing. I got 0.4694715628. Okay, it's a long, never-ending decimal when you are dealing with any of those. And so I want to take a look at these three triangles right here. I want to show you that you can look at them and see that they're all pretty closely related to each other. The smallest one right here is a 3, 4, 5 triangle. The medium-sized one is 6, 8, 10 for your side lengths. And you can tell that when you go from, you can tell that these two triangles, the green one and the blue one, are what we call similar to each other. They're the same shape but different sizes. And you can actually look at it and tell that going from the green one to the blue one, you have scaled up by a factor of 2. It's a very similar thing with the purple one. Going from the green one to the purple one, you've scaled up by a factor of 3. So all of these are right triangles. 3, 4, 5, you may remember, is one of our Pythagorean triples, and these other two triangles are just multiples of that, 3, 4, and 5. So what happens is when you take the sine and cosine and tangent of this 37-degree angle that's marked, we're going to start with the smallest one right here. When you take the sine, well, some old hippie, SOH, is sine opposite hypotenuse. Well, the opposite side is this 3. The hypotenuse is 5. So we'd have 3 over 5 as our sine of this angle. When you look at this triangle, if you're taking the sine of the blue triangle, that's 6 over 10, which if you reduce it down is equal to 3 over 5. It's the same thing if you look at this one over here. The opposite side on this triangle would be 9. The hypotenuse is 15, and 9 over 15 reduces down to 3 over 5. Okay, now look at the cosine. The adjacent is 4, hypotenuse is still 5, so we got 4 over 5. For the blue triangle, 8 over 10 reduces down to 4 over 5. For the purple triangle, 12 over 15 reduces down to the same thing. Okay, last one, tangent. It works the same way. Opposite over adjacent. Tripping on acid, TOA, tangent opposite adjacent. We got 3 over 4, 6 over 8, which reduces down, and 9 over 12, which reduces down. So the point of showing you all of this is to emphasize that it does not necessarily matter the size of the triangle. Okay, how long these sides are is not the important part. The important part is the size of this angle. Okay, because the sine of this angle, the cosine of this angle, and the tangent of this angle are going to be the same no matter what. Okay, a while back we called these trig ratios, and that's because they're ratios of side lengths. And these side length ratios are consistent every single time, no matter what. So here's what we're going to do. Okay, since those side lengths are consistent every single time, something you can do is actually just type it into the calculator. If you typed in sine of, like we did a second ago, sine of 28, you could type in sine of 35, and that gives you 0.5736. It doesn't matter how big your triangle is. If it has that size of angle, the ratio is always going to be the same. So what we're going to do is use that idea to solve some equations. Here are the steps. Okay, what we're going to do is we're going to find, from these diagrams, we're going to find the missing part that it's asking for. Now you can see in this diagram, in this triangle, that we've got one angle that's marked as 43 degrees. We know that it's a right triangle. We see that this side right here is a length of 11, and this side over here is unknown. Okay, so the first thing we want to do is identify the missing side, the one with the variable. Okay, and we can see that it's this side over here. And what it means by identify the missing side is asking the question, is this the opposite, adjacent, or hypotenuse? Is it the opposite, adjacent, or hypotenuse? The next thing we want to do is identify the given angles and given sides. And that's the same thing. This right here also applies to down here. Okay? What did they give us? Did they give us the opposite, adjacent, hypotenuse? What angle did they give us? Next thing we want to do is, now that we know which sides we're going to be dealing with, determine what trig function to use. Okay, so in this case, are we going to be using sine, cosine, or tangent? Up next, what we want to do is set up the equation, and you're going to see a pattern in all of these problems that we're about to do, that the equation is always going to be the exact same setup. All right, we'll talk about that. And then we use a little bit of algebra, we use the calculator, or we use the table that's in there, that's in your packet, to solve the equation. All right, so this is our first example of it right here. And we can see that when we look at this problem, the missing part, this side that's labeled A right here, that is the opposite side. And the reason this is the opposite side and not the adjacent side is because this is the angle down here that we're dealing with. This 43-degree angle is the one that we're working with, and this side does not touch it. This side is not attached to the angle that we're talking about, so it's the opposite side. The other side that's given to us, the side that is given, is the adjacent side. This is the side of the triangle that does touch our angle that we're working on. So we need to think about this. We've got we are going to be dealing with a problem that is talking about the opposite and adjacent side. We need to consider which of these three functions deals with the opposite and adjacent. So I think back to my mnemonic device. Some old hippie caught another hippie tripping on acid. And I see that TOA at the end is tangent, opposite, adjacent. Now we also know that the tangent of any angle equals the opposite over adjacent. So let's plug in the information that we know. The tangent of this angle is going to be the opposite, A, divided by the adjacent, 11. This right here is a fully functioning equation. All right, that is it. That is the whole of step 4, is to set up the equation. It's always going to be the trig, whatever appropriate function of your angle equals whatever the proper measurements are. Okay, and you're going to see that pattern again on our next problem. I'll point it out when we get there. Okay, so the point of this problem is to solve for A. The point of this problem is to find our missing side, right? So we need to figure out how to get A by itself. So we ask ourselves, in this equation, what is happening on the right side of the equal sign? And I see that A is being divided by 11. So I ask myself the question, how do you undo division? Well, you multiply. And what we're going to do is we're going to multiply both sides times that denominator. 11 times tangent of 43 equals A. And that does the trick. That gets A completely by itself, which is what we need. Now, here's the other thing you need to recognize is that the tangent of 43, that is just a number. Okay, the tangent of 43, if you're looking at the chart, it says that the tangent of 43 is 0.9325, or you could just type into the calculator, hit tan, and then inside the parentheses, 43, and it tells you that same number. So if you can take this tangent of 43, this number, times 11, that will give you the answer of what A is equal to. This right here is just the number taken from the chart, 0.9325. And we get 10.26. That means the length of this side is 10.26. All right, that's all it is. That is the end of the whole problem right there. That's all we were doing. All right, we're going to do a couple more examples, and then there are some Canvas problems related to this also. All right, so here's our next example. We've got our steps ready to go. All right, we're going to start by identifying the missing side. Okay, the missing part with the variable, you can see it right here, is the hypotenuse. The given side that it gave to us is this one up here. The given side is the opposite side. And we know it's the opposite because this 8 over here is in no way connected to the angle that we're dealing with. So we're looking for, what we're looking for is which of these trig functions is related to the opposite and hypotenuse. And when I look at our some old hippie caught another hippie tripping on acid, what I see is SOH. That OH is opposite and hypotenuse, right? So that would be sine. So we're going to set up our equation the same way we're going to do it on all of these problems. The sine of this angle equals the opposite side over the hypotenuse. Sine of 38 equals 8 over x. All right, so just like before, we see that our variable is inside of a fraction over here on the right side. Fractions, as we know, are just division. So how do you undo dividing? You multiply times the denominator. Okay, what we're going to do right here is multiply times x. Times x. And we do the same thing on both sides. Make sure you're doing the same thing on both sides. All right, so we've got x times sine of 38 equals 8. Now here's the question. X is being multiplied now. How do you get rid of this sine 38? Y'all, you need to recognize that sine 38 is just a decimal number. And if you type that into your calculator, you end up with a long decimal of 0.6157. Okay? If this were written down as x times 0.6157, you would immediately know that you have to divide that. And that's what we're going to do. 8 divided by that long decimal number, sine of 38, is what we're looking for. And that tells us that our hypotenuse length here is going to be about 13. When I type it in, it actually ends up being It ends up being about 12.994, but that's okay. We can round it up and call it 13. All right. On all of your Canvas problems today, it's going to be decimal approximations. All right, so that's how we get that x equals 13 right there. Our last example problem is this one right here, and we've actually got two variables. So we're going to be doing this process twice, okay? First, let's deal with the x. The x right here, it tells us is, when we look at it, it has to be the adjacent side, okay? We look at our angle that's marked as 20 degrees. This x is the one that's touching it, so that's the adjacent side. This 12, of course, that's given to us is the hypotenuse. So we've got an adjacent and hypotenuse, and when we look at our SOHCAHTOA, our some old hippie caught another hippie, adjacent and hypotenuse would be caught another hippie. So cosine, we set up our equation. Cosine of the angle equals adjacent over hypotenuse. Cosine 20 equals x over 12. This is very similar to the one that we did just a minute ago. How do we get the x out of this fraction? We multiply times the denominator. Multiply times 12 on both sides. 12 times cosine of 20. That is something that you can type directly into your calculator right there by itself. 12 times cosine of 20 gives us 11.3. That's the length of our adjacent side right there. Now, y, of course, since x is the adjacent, y must be the opposite. This is the side that doesn't touch the angle we're dealing with. So when we look at the opposite and hypotenuse being given to us, we look at the opposite and hypotenuse, we think of our mnemonic device, some old hippie would be sine opposite hypotenuse. So the sine of our angle equals the opposite over the hypotenuse. Sine of 20 equals y over 12, and we solve it the exact same way. We want to get our variable out of the fraction, so we multiply times the denominator. 12 times sine 20. Again, something you can type directly into your calculator. 12 times sine 20. And y equals 4.1. That's the length of this side. All right? If you're struggling on the Canvas problems, let me know. I need to know that sort of information so I can help you out, all right? That is all of the notes that we have for today. Y'all have a good one.